and welcome to the first of the two Keith Bryant shows, coming to you live from IPC APEX Expo in San Diego. Considered by some not to be the biggest electronics show that we visit globally, but definitely one of the most influential. Obviously its location close to Silicon Valley and close to the large manufacturing centers in Mexico make it a key venue for many of the people who have come here to exhibit and who have come here to speak and also listen at the technical conference. My first guest today is Dr. Ying. He is president and CEO of a company called Inke, focusing on R&D and manufacturing of high-end materials. I'm going to talk to him about a couple of his products, the BP265 and the SMT265EP, designed for the component level process and designed to make manufacturing and processing of the components much easier. So, welcome, Dr. Ying. Perhaps you could start by giving us a brief introduction to BP265.
Okay, thank you, Keith. BP256 and is a solder joint encapsulant adhesive, which used for the solder ball bumping process. Traditional solder bumping process use tack flux. They use pin transfer tack flux on the pad. Then put the solder ball on the pad, go to leaf flow, and they make the BGA CSP like this. After that, they assemble BGA CSP on the PCB. During this solder joint gets small and small, the people normally, customer, put the underfill to enhance this job test performance or some the reliability. Now, all the customer use the BP256 and do this exactly same as tack flux. No need to change any process. Leaf flow process or the pin transfer process, no need to change anything. Just the pin transfer BP256, this glue on the pad. Then put the solder ball on the glue and the leaf flow. After leaf flow, because BP256, the epoxy is transparent. So no need the cleaning process. So during the bumping process, they eliminate cleaning process. So another big advantage, this components assembly on the PCB and they no need underfill. So eliminate underfilling process, underfill materials. They can pass job test, according to the IPC standard, 200 jobs, no issue. And the thermal cycling up to the 3,000 to 4,000 cycles, no issue at all.
Okay, so basically you have a drop-in replacement that reduces the number of manufacturing processes that you have, and also improves the reliability of the product without any need for underfilling or corner bump strengthening, and all of these things. So that must be a very strong, let's call it a very strong selling proposition to the people who are currently doing a lot of processing.
Particularly, I think the number one packaging house, number two, and they study, and use this process.
And obviously, because you don't have the flux chemistry within your system, you don't have to worry about things that you can't clean with low standoff height and all the problems that the industry is seeing at the moment. Because as components get smaller, we all know it becomes harder to get cleaning solutions under them. You take away all of that stress.
That's correct.
Okay, so that's number one product. That's sounding like a good start. So the 256 EP, you can maybe explain a little of this too?
256 EP is a solder joint encapsulant paste. We mix solder joint encapsulant and mix with powder from the paste. This is not a traditional solder paste. This is epoxy. So they also, during the leaf flow, they form exactly solder joint as a traditional solder paste. But it's two different distinguished performance we try to deliver. One, we try to deliver low temperature solder, and you can use high temperature application. For example, SMT256 EP, they can solder at 230 like normal cycle alloy paste.
Yep.
And after solder, they can use for the high temperature application. So use a temperature up to the 300 degrees C. So industry, in order looking for the high temperature, the solder work very hard, try to develop new alloy.
Yep.
But we use this solder joint encapsulation easily to, overcome this disadvantage. The purpose, the principle is simple. After the solder formed and our glue, your binding, epoxy never melting, so they can use it for the high temperature.
That's great. So a lot of the high reliabilities, a lot of the automotive applications now where they're looking at under hood stuff, where they're looking at temperatures of 250, 260, 270.
Yes.
You have an ideal product solution for them.
Yes. Not only this for this package level automobile you mentioned, even for the SMT, the double-sided leaf flow, the normally industry use the red glue to hold the components, afraid the components dropped.
Yep.
So if you use SMT256 EP, they no need the red glue.
Yep.
So that machine and the materials, they eliminate.
Yeah. So it gets rid of also, I would guess, a lot of the thermal stress that you have when you start working above liquidus temperatures.
Yes.
Okay. So I guess my last question is, obviously you have high temperature covered very well with relation to the component, but we all know there's a big thermal mismatch between the PCB and the component.
Yes.
Is your product flexible enough to actually allow a little bit of movement when the circuit board is expanding and contracting, even if you're holding the component in up to like 200, 240 degrees C?
Yes, because the epoxy, normally this glass transition temperature is 130 to 150.
Pretty much the same as the circuit board.
Yes.
Yeah.
So when you go to the rest temperature, above the TG, they're flexible, they're like rubber.
Okay.
So they can tolerate this, city mismatch.
So actually you have very little thermal mismatch with the board because you're using epoxy material, which is the main material in the printed circuit board.
Yes.
So you actually have a thermal gradient which is pretty much the same as the board.
Yes.
So that must be also good for the high reliability applications.
Yes.
Okay, well, thank you very much for coming in.
Oh, thank you.
And thank you very much for giving us a very good explanation of what I guess are two of the new exciting products that are here at the show today.
Thank you very much.
Thank you.
Thank you for me the time for this interview.
Oh, my pleasure.
Okay. So we're done?
Perfect, we're done.
Okay, thank you very much.
Not at all.